Let's discuss the law of cosines, which will allow us to do work on oblique triangles, triangles that do not have a 90-degree angle. And the way I like to think about the law of cosines is it's very similar to the Pythagorean theorem, which does only apply to right triangles. So this is like the generalized Pythagorean theorem. Alright, so we're going to start with a triangle named in such a way. The angles are the capital letters A, B, and C, and the sides are the lowercase letters a, b, and c. And the A's are opposite each other, the B's are opposite each other, and the C's are opposite each other. So the law of cosines has three different forms, but they all come about the same way. So let's look at the first one that is very similar to the Pythagorean theorem. It starts like this. Side c squared equals side a squared plus side b squared. So that's the beginning of the first law of cosines formula, and it's exactly the same as you're used to seeing the Pythagorean theorem. But of course there's a bit more to this. Now we've got to subtract off a part. So minus 2ab. So notice that the sides that are used here are the same as the other sides used on the right hand side of the equation. So on the right hand side of this equation you're only going to have sides a and b, and on the left hand side of the equation you're only going to have the other side, c. Alright? So you've got minus 2ab times, now we need to get an angle in there, so times the cosine, for law of cosines, times the cosine of angle c. So now you can see the only sides on the right side are the a and b sides. Side c is on the left, and angle c is on the right. So angle c, the angle on the right, corresponds with the side on the left. So side c is on the left, then angle c has to be on the right. Okay? Also, angle c is between sides a and b. Alright, it's the included angle between those two. So notice a and b are on the right hand side along with its included angle, angle c, and angle c also matches up with side c on the left. It seems like a lot, but it's very valuable to be able to understand all the parts of this formula without memorizing the letters. Okay? So there are two other forms, and it's simply rearranging this. For example, if I have b squared over here, then the sides on the right will be a and c, so a squared plus c squared minus 2ac times the cosine of angle b to match the side on the left. And angle b, again, is included between sides a and c, right? Okay, so that's the second version. Means the exact same thing, just different labels. And finally, you can guess the last one. A squared equals b squared plus c squared minus 2bc times the cosine of angle A. Alright? And so you can use these equations to solve for various parts of an oblique triangle, or a right triangle if you'd like. So in particular, if you ever want to solve for angle C, you have to use this top version because it's the only one that involves angle C. So lots of times, well, if you're given an angle, you're stuck with only one of these to use. If you're not given an angle, then you'd have to know the other three parts in this equation, right? There are four things involved in each of these. All three sides and one angle. So if you don't know an angle, you better know the other three sides in order to use one of these formulas. And that's different from the law of sines. In the law of sines, if you know all three sides, you can't do anything because you need at least one angle.